Hello everyone, this is Aditya and today we are going to discuss simple harmonic motion for JEE. Someone in the comment section said me to teach it for JEE, so that is why I am teaching it. And of course in that we are going to cover all the concepts which are required for JEE, right? And I will try to demonstrate using simple pendulum. I don't have much equipments right now because I'm not at the campus, but I have made a simple pendulum using a ball and a rope. Of course, I will use my hand as the point where I will hinge it, and then I will show. Right. We don't need much high equipments for anything, just a determination. Right. Okay. So now let's start with the lecture first of all, and please don't ask for these notes because it is only for my purpose. That what I need to teach. It's not relevant to your preparation, right? That is why. Okay. So now let's start. So before understanding simple harmonic motion, you need to study what is oscillations. Well, oscillation is just the back and forth motion or to and fro motion of a body, right? If I say in simple words, there's a lot in that, but of course we don't need to worry much about it. Okay. And oscillations can be of two types, like linear and angular, right? And it can be like periodic and non-periodic, right? Okay. So the oscillations which are periodic or periodic oscillations are termed as harmonic motion, right? Okay, right. And the motions and the harmonic motion which are simple are called simple harmonic motion. What do I mean by simple harmonic motion? I said the harmonic motion which are simple. No, it's not like that. Basically the equation, the harmonic motion have many equations in it, and the simplest equation which we are going to use is termed as simple harmonic motion, right? And in that we are going to use force proportional to the displacement, and if I talk in vectors it is like this is the simplest possible equation in the harmonic motion, so that is why it is termed as simple harmonic motion, right? So it is of course simple, right? But for you all it is not simple. Okay, so now let's understand that what do I mean by this. Okay, so suppose you have a spring block system. Of course SHM is also of two types, linear and angular, right? Let me write it completely. And you can take spring block system as an example of linear spring block system, right? And for angular you can take this example of a simple pendulum, right? Okay, so suppose this is your mean position. Don't worry about that, what is meant by mean position and what is meant by the extreme position. We will discuss it. Suppose there is a block at the mean position, right? And imagine that it is connected to a spring. I can't draw it like this on it because it will look a lot messed up, so that is why. This is your mean position, x is equal to 0. This is your extreme position, this is your extreme position. And suppose the particle is going like this. Let me show it using a pendulum. Of course it is example of angular then, but of course the cases are similar. Okay, okay. So right now the simple pendulum is at its mean position, right? Okay, now you displace it like this and you left it. What you see, the pendulum moves like this, right? Of course it is angular, so that is why it won't be similar to this, but the cases are similar, right? It is at mean position, right? It goes like this, then it goes like this. Okay, so what is happening over here is this: the particle just went like this, means from the mean position it went like this to some distance, then it reached back, then it went to some height, then it again reached back to its mean position, then it again moved to another extreme position, right? So what you are observing is that after certain interval of time at a particular point the velocity is becoming zero, right? And that point is the extreme position, right? Which means the force is acting in the reverse direction of the motion of the opposite direction of the motion of the body, right? So that is why force is proportional to negative of x vector, the displacement vector. Of course, this is the equation of simple harmonic motion. This is the concept of simple harmonic motion, right? And from all this, we derive many expressions like this. And of course, we will discuss it in great detail in some time. Just for now, that understand that force is proportional to the negative of the displacement vector, right? So basically, as you are moving towards the extreme position, the force is increasing. The magnitude of the force is increasing, and at extreme, the magnitude of the force is maximum, and at mean position force is equal to 0. There is no force acting on that, okay, since x is vector is equal to 0, right? Now let's erase all this and let's see that what we need to learn next. Okay, yeah, one thing I forgot to tell over there, that the force, be it the body is over here or the body is over here, the force is always directed towards, force always directed towards the mean position, right? Right, this is the mean position, right? Okay, understood. This is the thing which you need to remember in me, okay? And basically if you remove this quantity, this proportionality sign, you get f is equal to minus kx vector, right? And k is called the spring constant, and force is referred to as restoring force. Why restoring force? Because it is restoring the motion of the body, right? It is providing the oscillations. That is why it is referred to as a restoring force, right? Now let's see what we need to study. Okay, now we are coming to some concepts. So of course we are discussing right now linear SHM. So we proved that F is equal to negative kx, right? What is F? F is equal to ma, the mass of the block, into the acceleration of the block, is equal to minus kx, right? A is equal to minus k by m into x, right? This is correct. And we know that acceleration is equal to dv by dt, right? And this is equal to d2x by dt square. If you don't know, you should remember this, okay? Acceleration is the second derivative of the displacement, right, with respect to time, okay? So you can write it as d2x by dt square plus k by m x is equal to 0, and this is the differential equation of the linear SHM. And d2x by dt square is equal to minus k by m x, and over here this quantity, I mean this quantity is referred to as the angular velocity. Omega square is equal to k by m, right? And so we have omega is equal to root k by m. So we have 2 pi by t, the time period of the motion. What do I mean by time period? Well, let's see first of all that. Let me again show you the pendulum. This is your mean position, right? You bring it to its extreme position and you leave it. The time taken to complete one oscillation, right? This time, right? Okay, understanding? So basically the time taken to complete one oscillation is referred to as time period, and 2 pi by t is referred to as the angular velocity, right? Many times we refer to as angular velocity and angular frequency many times. It depends upon whatever thing you are taking into reference. For waves, we generally refer to as angular frequencies, right? And in the case of circular motion, we say it as angular velocity, right? Is equal to k by m, right? So t is equal to 2 pi root m by k, right? This is the time period. It depends upon the mass and the spring constant, right? 2 pi is a constant, right? And such type of differential equation has a unique solution, means if you study quantum mechanics or even the classical mechanics to a high level, you will understand that that this equation is equal to x is equal to a times sine omega t plus phi, right? Where a is the amplitude or the maximum displacement, and omega is the angular frequency or angular velocity. T is the time. It is not the time period, it is the time at what interval you are measuring. For example, t is equal to 2 seconds or t is equal to 3 seconds, right? And phi is called the initial phase. What do I mean by initial phase? Well, suppose I have to again take this pendulum. Of course, it's linear SHM, but we can understand it using SHM, using angular SHM, right? Right. So this was your mean position. At this point, the phi, the angle, the initial phase is equal to 0. You bring it over here, the phase will not be equal to 0 again, like this. So what is phase actually? Well, let's. So this is your body. Suppose at t is equal to 0, the body is over here, and this is your mean position. At some distance x naught, suppose. You can express this in terms of initial phase phi, right? This distance can be expressed in the terms of the phase, right? The initial phase, that where the particle is, and we study it using a circle. Let's see how. Okay, this is your circle. Okay, and suppose the particle is over here at some point. Initially at t is equal to 0, its angle of phi, and after t time it will cover a distance, it will cover an angle theta. And you know from the distance that from the circles, you know that theta will be equal to omega t, right? The angular velocity into time, right? Okay, so instead of theta you can write omega t, right? So what is the complete angle over here? From this, suppose this is your x-axis and this is your y-axis. The complete angle will be equal to, let me erase this. You get omega t plus phi, right? Okay, and this is the amplitude, the maximum displacement, right? Or the radius of the circle in this case. And when you take its projection along the y-axis, what you get? Y is equal to a sine omega t plus phi, right? Of course, if you take this as your y-axis and this as your x-axis, then you will get x is equal to a sine omega t plus phi. And this is how you understand the concept. Phi is basically telling where the particle is initially at t is equal to 0. If phi is equal to 0, which means that the particle is at its mean position, right? Okay, so I hope you are understanding that what I meant from all this. And now let's move on to the next topic. So as discussed, x is equal to a sine omega t plus phi, right? And yeah, omega t plus phi can be said as phase, right? It is called phase, and phi is called the initial phase at t is equal to 0. So you can say initial phase is the phase at t is equal to 0, right? Okay, understood what is it? Okay. Now differentiate this equation. Let's differentiate what we see, what we get actually. Dx by dt with respect to time, of course, is equal to a omega cos omega t plus phi, right? You get this thing, right? And you can simplify it further. You get a omega times 1 minus sine square omega t plus phi, right? Of course, you should know this identity. It is sine square theta plus cos square theta is equal to 1. I've used that. Okay. So you get a omega times, what is sine? Sine omega t plus phi is equal to x by a. Of course, you can see it. It is equal to x by a, right? Substitute this value. 1 minus x by a whole square is equal to a omega times a square minus omega minus x square by a square, right? And you get omega times a square minus x square is equal to dx by dt. And what is dx by dt? It is called the velocity. Is equal to velocity, right? Okay. Of course, all this is in the form of vectors, but I'm not writing it like that. But you all know, okay? Because we are only worried about the magnitude side now. So we can write velocity as a omega. First of all, let's write it its form. Dx by dt is equal to a omega cos omega t plus phi is equal to omega times root a square minus x square, right? And this is the expression for the velocity in the case of SHM, linear system, right? Okay. And if you differentiate it second time, you will get the acceleration d2x by dt square is equal to the acceleration as we know. And when you differentiate this, you get a omega into negative omega into sine omega t plus phi, right? You get this, okay? You get negative a omega square into sine omega t plus phi, right? And that is why you get, what is a times sine omega t? It is equal to x. So you get d2x by dt square is equal to negative omega square into x, right? And of course, if you want to put vector, you can put vector over here, right? And that is why when we had said that d2x by dt square is equal to minus k by mx vector, so that is why we had said that k by m is equal to omega square on comparing these two equations, right? And now you know that why I had used that, okay? So I hope that you understood linear SHM to some extent, and now we will see some other concepts in it if there is anything left in this. Yeah, we need to work upon the energy, right? So let's see the energy, and we will move on to the further concept of that. So now let's see the energy in the SHM. So we know that kinetic energy is equal to half mv square, right? Okay, now let me write the equations. X is equal to a sine omega t plus phi, v is equal to a omega cos omega t plus phi, or omega into root a square minus x square, and a acceleration is equal to negative a omega square sine omega t plus phi, and it is equal to minus omega square x, or something like this. So we can substitute the value of velocity from this equation, and you get half m times omega root a square minus x square whole square, right? This you can get, and you get m by 2 into omega square a square minus x square, right? You get this thing. What was omega square? It was equal to k by m, right? You substitute it over here. You get m by 2 into k by m into a square minus x square, right? You get this thing. M and m get cancelled, and you get k by 2 into a square minus x square, right? This is the one form. Let me write k e over here, right? Because you will get confused between them. Okay, and you can write it in the form of this also, that kinetic energy is equal to, so let me write another equation. Kinetic energy is equal to k by 2 a square minus x square, right? And when you substitute the velocity as this, you get half m into a omega cos omega t plus phi whole square, and you substitute half m a square omega square cos square omega t plus phi. You get this thing, okay? And you can substitute again value of the omega. You get k by 2 into a square cos square omega t plus 5. And this is your homework to check how I got this from here to here, right? Simply I put k by m and m got cancelled. So it is equal to k by 2 a square cos square omega t plus 5, right? We get this thing. Okay, now let's see the potential energy, how we calculate the potential energy of the system. The potential energy is equal to half k x square, right? And here the value of x already. You get half k into a sine omega t plus phi whole square. You get k by 2 into a square into sine square omega t plus phi, right? You get u as k by 2 a square sine square omega t plus phi, right? You get this thing. Okay, u is equal to k by 2 a square sine square omega t plus phi, right? You get this thing, okay? And what you can do is that since total energy is equal to u plus k E, right? The potential plus the kinetic energy, the mechanical energy is equal to this. It is equal to k by 2 a square sine square omega t plus phi plus what is the form of energy over here? This, right? You get k by 2 a square cos square omega t plus phi, right? You can take k by 2 a square as common, you get sine square omega t plus phi plus cos square omega t plus phi, and sine square theta plus cos square theta is equal to 1, right? So you get k square a by k a square by 2 is equal to total energy, right? So T is equal to Ka square by 2, right? And this is a constant value. Of course, the total energy should be constant, right? Now let's plot it graphically, that what we get. Okay. And sometimes it is asked to find the average value of the kinetic energy and the potential energy. So let me write it. U average is equal to 1 by 4 Ka square, and Ke average is equal to 1 by 4 Ka square, right? You should remember this. It is asked many a times, okay? And now let's plot graphically that how the things are going. Okay, we don't need this axis. This is your amplitude, negative a to a, right? And yeah, one thing I need to tell you all, that at the mean position the potential energy is the minimum, right? I mean that at the mean position u is equal to 0 or minimum possible value, right? And at this point the kinetic energy is equal to maximum, right? And over here u is equal to maximum and kinetic energy is equal to 0. Basically it is at rest. And over here also the same case, u is equal to max and k is equal to 0. The kinetic energy is equal to 0, right? This is how the things are going. This is how the energy is getting transferred. And this is what distinguishes the mean position from the extreme position, right? Now let's see how we graphically express this thing. So this is your total energy. This is like this. Of course it is constant and it is going like this, right? Okay. And of course you can compare this and this. You get, since you know u is equal to t minus ke, right? T is equal to u plus ke, so t is equal, so u is equal to t minus ke, right? So you put ka square by 2 minus ka square by 2, I mean k by 2 into a square minus x square, and when you solve you get u is equal to half k x square, and of course this is the original equation. So This is your x and this is your energy, right? So the potential energy is varying like this in a parabolic, in a upward facing parabola, right? This is your u, this total energy, and the kinetic energy is behaving like a downward parabola, right? Like this. Okay. Like this. It's graphical. It's means rough diagram, so that is why it's not that appropriate. It's not that good, but it's okay. And notice that at 2 points it is having the same energy. That means the value of the kinetic and the potential is same, and it happens at negative a by root 2 and at a by root 2, right? Means this is the value. At this you will get, and your work is to find that why it is so. Just equate ke and u and calculate the sine and cos from that, and you will get the answer, right? And now we have to, yeah, there's one more thing which I need to tell, not in this. Of course, applications you have to do on your own. I'm just telling the theory in the best possible way in which I can, so that you understand. Maybe I'm not able to tell properly, but it's okay. You have many other options also. But if you all are understanding this, then please follow me. That after that, please do solve many problems related to this SHM, right? So now let's see. Suppose there are two particles, and in this just formula is required. Suppose two particle having, means there are two particles having phase phi and they are undergoing similar SHM, right? Okay. So in that case, the minimum distance between them is equal to 0, and maximum distance between them is equal to 2a sine pi by 2, right? Okay. This is 2a sine phi by 2. You should remember this, and it will be given in the question. You have to just substitute the values and you will get the answer, right? Now let's see the series combination, right? How the series combination is going of springs, right? Okay. I mean, not just the series combination, the spring combination. The spring combinations. First is the series one, and the second is the parallel ones, right? In series, it's somewhat like this, and there can be n springs, and you are applying a force F, and the force is getting equally, means the each spring is experience the same force, that is F, okay? And in this case, it is somewhat like this, and we are applying force, and in this case the force is getting distributed over here, right? So suppose over here it is F1 and it is F2, and in this case, but in this case the displacement for both spring, and if there are n for n spring is same, and in this case, suppose in this case the elongation is x1, and in this case it is x2, and so on and so forth. In this case the force in each spring is same, right? Okay. So you get F is equal to k1x k1x1, and F is equal to k2x2, and so on and so forth, right? So you get, in this case, in the series one, so we get total elongation is equal to x1 plus x2 and so on and so forth. So we get f by k equivalent is equal to f by k1, right? Like this, right? F and F gets cancelled, is equal to 1 upon k1 plus 1 upon k2, and so on and so forth. Means the resistance parallel is similar to the resistance is similar to the spring series, and in this case the force is same. I mean, the force is getting distributed, the elongation is same. So in that case, F1 is equal to k1x, and F2 is equal to k2x, and so on and so forth. So F is equal to the summation of the forces. So you get kx is equal to k equivalent into x is equal to k1x plus k2x and so on and so forth. X and x gets cancelled, so you get k equivalent is equal to k1 plus k2 plus dot dot dot, means the series combination of the resistances is the parallel combination of the spring system, right? And is something which is necessary to be learned. Let me write this also, that k equivalent is equal to sigma ki in the case of parallel, and 1 upon k equivalent is equal to sigma 1 upon ki the case of series, right? Okay. And yeah, there is a case many people confuse in this. They say that it is series, no, it is not series, it is parallel. When you displace it like this, it will get displaced, the spring gets displaced by x, and over here also x, right? So this is also a case of parallel, and in this case k1 plus k2 will be the equivalent the equivalent spring constant, right? So now let's see some other concept. Let's see what is there next, which we need to cover. Yeah, now we come to physical pendulum, right? What is a physical pendulum? Suppose I have this sheet, right? It will have its center of mass somewhere over here, right? In the midway. Let me tell it like this. Yeah, no, the center of mass will lie over here. So if I hold it like this, it stays in its position, since the point where I have hinged it is in the line of the center of mass. But if I hold it from here, let's see what happens. It got tilted to make sure that the point where it is hinged and the point of the center of mass, they both are in same line, right? That is why so this is the basic concept over here, and now we will see that what is happening. So suppose this is your some body and you have hinged it over here, okay, right? And now, and of course it is free to rotate, okay? And over here the center of mass lies over here, and this is your length L, right? Now suppose you displace it from here to here, like from you displace it like this. Center of mass is over here and it is got tilted by an angle theta, right? Okay, so in that case the torque which will be developed, it will be equal to mgl sin theta. Of course it's your work to calculate because it is a very simple thing, and it is equal to I times alpha. This is the from the rotation, it is moment of inertia into the angular acceleration. And for small theta, we have sine theta is approximately equal to theta, right? You all know it. So you get mgl theta is equal to I alpha. So we get alpha is equal to mgl by I into theta. So you get d2 theta by dt square. Of course, you should know this from the rotation chapter, and it is equal to mgl by I into theta, and it is similar to that equation, right? That d2x by dt square is equal to omega square into x, right? So which means this is the omega square and it is equal to mgl by I, right? So you get omega is equal to mgl by I, right? And using this you can make many calculations, right? Okay, and of course you can from this calculate the time period also. Let me calculate that even. And of course the moment of inertia is the moment of inertia at that point where it was hinged, right? Okay, you should know that. So now omega is equal to, let's calculate the time period. So 2 pi by t is equal to root mgl by I. So you get t by 2 pi is equal to root I by mgl, and so we get t is equal to 2 pi root I by mgl, right? And in the case of a simple pendulum, we assume that the pendulum has a very small dimension. So in that case, it can be treated as a point particle, right? So that is why we get t is equal to 2 pi. And what is the momentum? The moment of inertia of a point particle, it is equal to ml square by mgl. So we get the time period of a simple pendulum, sp I can say, simple pendulum, is equal to pi root l by g, right? And now let's see this simple pendulum in a great detail. So this is your simple pendulum. Of course, I can't change the value of g, but I can change the value of length. Okay? So I have taken a small length, so it should have a small time period. It covered it in less time. Now let me change the length of the pendulum to a great height. Okay, this is your pendulum. I hope it's visible. It took a great time as compared to before, right? So this is how the time period varies with length, right? In the case of simple pendulum, right? And let's see if there are anything left. And okay, so with this we come to an end to our lecture, and of course superposition of SHM is left. But before telling waves, I can't tell that because it will be like waste of time because you won't understand that. So I'm leaving that topic for now, and if you want, you can cover it from after covering the waves, or I will make a short video on it. Okay, but this is the basic idea of the SHM, that how the things are going. And yeah, there are problems like earth, like we are digging a canal across the earth at some distance from the center of the earth and somewhat like that. Those problems I will cover it in a separate lecture, but for now the theory purpose it is enough, right? And if you want, of course you should study from books even, and you should practice problems, and there might be some concepts which are left which you need to study on your own. And if anything I feel, and if you have any doubt, you can comment me in the comment section. And of course, first of all is taking care of yourself. So please relax and subscribe my channel, and please take care. Bye bye.